Hi guys, and welcome to the video for the logarithms and the change of base rule. So in this video, I'm going to be going over the definition of a logarithm and its relation to exponential expressions equations and how to rewrite logs as exponents and vice versa. We are doing this because logarithms are the reverse of exponents, and these are an integral part of calculus and pre-calc. You'll know you can do this when you can switch between a logarithm and an exponential expression and change the base of a logarithm to calculate it. So let's get started with what is a logarithm. Logarithms are the reverse of exponentiation, exponents. They are another way of writing an exponential expression. Let's consider that we know that 2 raised to the third power is 8, represented by the exponential equation shown below. 2 to the third power equals 8. And they're color-coded for the reason that this is also expressed by the logarithmic equation log base 2 of 8 equals 3. So you can see where the 2 fits in, where the 8 fits in, and the 3 fits into a log equation, into a logarithmic equation. So you might be asking yourself, but what does log mean? Log is short for logarithm. Logarithms are the inverse function to exponents, meaning they are the undo button for exponents. Everything in math has an undo button. Addition is undone by subtraction. Multiplication is undone by division. Exponents are undone with logarithms. That means that they are a quantity representing the power a to which a fixed number, the base b, must be raised to produce a given number x. The logarithm base b is denoted as the log of base b for x of x equals a. So let's take a little bit of time to talk about bases and the basis of logs. All logarithms have a base. Every single one of them. That is the basis for how to create an exponential equation from them. Sometimes a logarithm is written without a base, like this. The log of 100 equals 2. This means that the base is really 10. It's called a common logarithm. Engineers love to use this. On a calculator, this is our defined log button. When you press log on your calculator, that is what your calculator is assuming, that it is log base 10. It is how many times you would need to multiply 10 by itself in multiplication to get the desired number. So in this case, how many times do I need to multiply 10 by itself to equal 100? Well, twice. 10 times 10 equals 100. So 10 squared, 10 to the second power, equals 100. Another base that is often used is called E, Euler's number, which is approximately 2.71828. This number is a special number derived by the German mathematician Euler, and he specially denoted that this number used in certain ratios, if you create a logarithm with this base, like log base e, we would denote it as the natural log. Natural log equals log base e. So if you write, you would see ln, lowercase l, lowercase n, and this button on your calculator is a log with a base of e. Mathematicians use it all the time. So if you press the natural log button on your calculator, it is creating a log with a base of e. So it would be saying how many times do we need to use the letter e or multiply 2.71828 times itself in order to create a desired number. So it's just like a common log, except it is based on Euler's number instead of 10. So we have interchangeable forms. The two forms below are interchangeable with each other. We will be working with the logarithmic form as well as the exponential form, but it's important to understand that when we write something in the logarithmic form, we are writing an equivalent expression essentially in exponential form. 2 raised to the power of 4 equals 16. And then you can see in the logarithmic form that we would say the log with a base of 2, because it is the base of 2 in the exponential equation, of 16, the 16 is in green, equals 4. And 4 is in red. Both equations describe the same relationship between the numbers 2, 4, and 16, where the base is 2, the exponent is 4, and then the result is 16. So if you want to convert a logarithm to an equation, exponential equation in back, we do what is called the loop-de-loop method. You do a loop-de-loop and pull, and your logs are looking cool. That's a SpongeBob reference for everybody that understands that. Essentially, what you're going to do to do the loop-de-loop method is go down and around the logarithm, like a loop-de-loop. So what I mean by down and around is you're going to start with the base b, go down and around the equal sign, and then you're going to hop back over the equal sign like a loop-de-loop. So we're basically looping around the equal sign in order to rewrite the exponential equation correctly. So the log base b of x equals a turns into b raised to the a power is equal to the number x. So you would write it as b raised to the power of a, set it equal to x. If you want to undo this, you use the same loop-de-loop method. You go down and around the equal sign and then ride back over, creating a loop, and it would be b, the log base b of x equals a. And you can see that red b goes around to x, green x, and then hops back over to a, and that is the order which we're going to fill in the pieces of our logarithmic equation. Base b, result x, and power a. So we're going to jump right into rewriting the expression in exponential form. Here's an example. I'm going to do the loop-de-loop method and go down and around the equal sign, and then go back over. So this would turn into the equation, the base of 7 raised to the second power equals 49. And we're going to just analyze this for a second. The equation that you write should absolutely be true and make sense in context. This is correct because if I go onto my calculator and type in 7 to the second power, I do in fact get 49. If you write it incorrectly, you may get variations. Okay, so this is the correct answer. Underneath, here are some incorrect variants that I've seen people write before. Don't do these. I've seen people go 7 to the 49th power equals 2. Or I've seen people do 2 to the 49th power equals 7, which is also wrong. And I have also seen 49 to the 7th power equals 2. Essentially, what I am telling you guys is put these into a calculator. 7 to the 49th power, that's not 2, okay? It is not 2. 2 to the 49th power, that is not 7. 49 to the 7th power, that is not 2. Okay? The equation that you get should absolutely make sense and be completely verifiable on your calculator. If it's not, like if you do it and then you check it and it's not true, you did something wrong. That's the reality check here. So let's try it backwards. Rewrite the expression in logarithmic form. So I start off by writing the abbreviation log. I start off by writing the abbreviation log, and I'm really struggling with my G. Okay? In order to put the base, okay, we need a base here. We need a number to fill in here. And we need the power over here. So we're going to do, we're going to use the reverse of the loop-de-loop method, and that's the order in which we're going to fill it in the logarithmic equation. So down and around. We start here, go down and around, and then we come back over. So we start with 13. That's going to be our new base. And then because we went down and around to the 169, that is what's going to go into the parentheses. And then the last thing that we came to over here is the power. So when we do the loop-de-loop method a second time like this, the resulting equation should be the exact thing that we started with. So if I do the loop-de-loop method again, my check here is that if I follow the loop-de-loop method again, I would get 13 squared equals 169. And that is exactly what I started with, so we 100% did it correctly. Okay, now what we're going to talk about is what's known as the change of base rule. Our calculators are only programmed to handle logs with a base of 10, common logs, or natural logs. We must use the change of base rule to calculate logs that have bases other than 10. If you have a newer calculator, one of the TI 87s or whatever, the one that's in full color and has all those very awesome variable options, it does give you the ability to type in a base for logarithms. That's fine, and you can 100% do that. You can type in the custom base. That's no sweat. However, the change of base rule must be used for any older calculators, such as the ones that you are provided to by the school. So to calculate a log in a base other than 10, you're going to take the log with a base of b of x, and you're going to set it equal to a fraction of the common log of x divided by the common log of b. And then that expression, the common log of x divided by the common log of b, is what you're going to type in the calculator. And that is how you would calculate that on your calculator. We also know that you can use the log base b of x is equal to the natural log of x divided by the natural log of b. So it's essentially reversing the order with the natural logs, putting the b on the bottom, the x on the top. It is not reversing the order, but it's using natural logs instead in order to calculate the value of your equation. So now what we are going to do is we are going to take a look at some examples of using the change of base rule. So on this problem here, I've added lots of side thoughts that I'm going through in my process just to kind of illustrate exactly what I am doing in order to calculate log base 4 of 22. The problem is essentially saying, what value do I need to raise 4 to in order to get 22? Another way of thinking about it is, how many times do I need to multiply 4 by itself to make 22? So I would say the log base 4 of 22. So that's what we're going to do here is we're going to set that equal to a fraction. And I'm going to move it down, actually. I'm going to move this down here. It would be the log, and we're going to do the common log, so we can use it for our calculator, of 22, divided by the common log of 4. Now, in order to actually calculate log of 22 divided by log of 4, I absolutely need a calculator for this step. There is no way around it. You 100% need a calculator for this step. So essentially, there are plenty of free calculators out there for you to find, but if you have the school calculator, you're just going to type it in like that. In order to type it into the calculator, you're going to type log of 22, close the parentheses, divided by the log of 4, and close the parentheses again. And what you get is a decimal, 2.229715809. Precision-wise, we're going to cut it off right here. And we're going to use the 7 to round the 9. So this stuff here is not relevant at all. We're going to use the 7, so it's 4 decimal places. The 7 is going to round the 9, and the 9 is going to round the 2 here because of the fact that it's a 9. So 7 will round the 9 up to a 0. So what we're going to say is that the log base 4 of 22 is approximately, so we're going to use the approximately sign, 2.23. Because the 7 rounds the 9 up to a 0, the 0 forces the 2 to become a 3. And what we're going to do is check this. We should always check these when we do them. A simple check will prevent us from getting so many problems wrong. So we will rewrite it using the loop-de-loop method. This is how we're going to check it. Rewrite it as 4 to the 2.23 power equals, what does it equal? So we're going to type it into the calculator, 4, and then the up arrow key, 2.23. When we do, we get 22.0086, and then that's what's going to create our, we're going to start rounding. The 6 is going to round the 8 up to a 9, so we get 22.009. If you are within if you are within a couple hundredths of the answer, like 22 here, that is entirely within the rounding tolerance. If you are more than a couple hundredths off, so if you're more, like if this number here is more than a couple digits off, I'm talking like 4, 5 at most, you rounded incorrectly, or you may have the wrong answer. However, in a situation like this, 22.009 is absolutely close enough, entirely within the rounding tolerance, to say that 22, or 4 to the 2.23 power, is correct. So the log base 4 of 22 is equal to 2.23. And then we're going to calculate log base 5 of 125. I'm going to kind of cut through all the other thoughts here, but essentially the question is asking you this, using the loop-de-loop method. It's essentially asking you 5 to what power equals 125. So in order to calculate it, what you will do, log base 5 of 125 equals, and then we're going to take the common log of 125, and divide it by the common log of 5. And so I go to my calculator and I type the log of 125, close the parentheses, divided by the log of 5, close the parentheses, and it just so happens, I'm going to just copy this, that the log here is exactly 3. So what I can do is then use the loop-de-loop method, and I want to check it. Okay, so the check would be, does 5 to the third power equal 125? Is this true? So you're going to go to your calculator, and you're going to type 5 up arrow 3, and you do in fact get 125, so we have done the calculation correctly. So that's it for this video, guys. In summary, we learned the definition of a logarithm. We covered what a base of a logarithm is, as well as what the common log and natural log are. We went through how to convert logarithms and exponential equations into one another. And we explored what the change of base rule is and how we can use it to calculate logs on our calculators, despite the fact that they're only programmed for common logs. So that's it for the video, guys. Thanks for watching, and I will see you in the next one.